Hello everyone, how are you doing? Good evening. So, how is your open source journey with AI agents and with the open source track going on? I am good as well. Hi. So, today we have another session for AI agents track. I want to see how many of you are actually contributing or participating as a part of AI agents track. So just write AI if you're part of AI agents track and open source in case you're participating from the open source track. All right. Good to see we have AI and someone from open source as well. So, getting into the session without much delay, today we are going to talk about building agent workflows. And today we are joined by Aniruddha, who is from Smartly team, and he would be explaining all the things to us. So, Aniruddha, you can take the session now.
Hi everyone. Hope you're doing good. I can see so many comments about people from like they are from AI track and all. So I guess you guys are interested in it, right? Can you just spam in the comment like how many of you have actually worked with AI and how many of you have built agents till now? Like any interaction with the AI agents? If yes, just spam yes, AI, whatever you want. Great, I can see a few people saying yes. Wow, fine. So, we had like previous session regarding this AI agent track. In that, we understood like how the AI agent works, what are LLMs, what is RAG, and we were uh, able to actually understand the behind the scenes of AI and agents. But now today is the time like you don't want to keep those AI agents just in your notebooks or not only restricted to your personal projects, but you want to actually use those AI agents to actually create an impact and you want them to actually serve some kind of purpose and some kind of thing that you actually use the AI. So you want people to use what you have created. And for that, you cannot simply just go and deploy the Jupyter notebook that you have created or the normal codes which you have created in your local systems, right? And for that, we will actually have to create the production grade AI agents. The agents should be able to actually handle the real world use cases, real world uh, challenges, and still survive. And that is what we are going to understand in this today's session of building production grade AI agent workflows. Uh, so, how many of you are excited to learn this today? Like, I just want to know how many of you are excited about this thing. Please spam in the comment yes or yes, I am interested. Yep. All right. So basically, before starting to understand what AI agents are and how AI agents work, let's understand what AI is. Let's understand this with a very simple analogy. Let's consider AI as a brain. Brain can process everything. Brain can actually understand things. Brain can use signals, but without hands, without your toes, without your tongue, what are this signal doing? They are of no use without these body parts, right? In similar way, when you have AI agent can understand everything, but AI can understand everything. But without AI agents, these AI is basically useless. We cannot use it without AI agents, right? We want the AI agents to actually serve some kind of purpose. Hands, toes, tongue does for our brain, and that's how we are going to understand AI agents. Uh, Before this session dives in, I want you to guys like give a complete lock-in for like next 60 minutes so that we can understand how the AI agent works in the production. And apart from that, if you have any kind of doubt on anything, just simply put it in the comments. I will surely answer that for you. Okay. Uh, Moving on to the next slide. So today's agenda is very simple. We actually have to go to the four missions today. The first mission is to understand the core problem why we need the production uh, guidelines for building an AI. Why building in normal environment doesn't work. Second thing we are going to understand is design pattern. This is the second mission we have to understand. Third mission is to pick your weapons. You guys need to use multiple tools and multiple dependencies, and which dependencies to use, which tools you are going to use will be deciding in this mission. And the final mission is to put all these pieces together and simply build and shape it so that the whole world, everyone can use what you have created and what you are trying to build. Is that clear, everyone? Okay, so let's move to the next slide. The core problem, understanding why the notebooks like the Jupyter notebooks or Google Colabs we use doesn't work in the real world. So the core problem lies between that the Jupyter notebook or the Google Colab, they are the virtual environment which simulates the whole environment of how you code and everything. But the real system doesn't work that way, doesn't work in a closed system. The real world scenario can be anything. It can happen like at the any point of time the system can break. At some point of time, you can get like thousands of users on your AI system asking for queries. And at that time, if your AI agent is not able to handle those kind of queries, what you will do? And this can break the system. And this is what we can understand with this core problem. So let's see what the problem actually is. Just imagine you are having a RC, remote control car, and you are playing with it. Let's say the car crashes into the wall, the remote control car. Would you think it affects anyone, even to you? No, you know that if it crashes the wall, it's all right. I put that car back and then I again drive it and play with it, right? But consider the scenario you are actually building a autonomous self-driving car. If in case the self-driving autonomous car crashes the wall, is that scenario very similar to what happened to previous one? No, absolutely not, because this time things will be very serious. Why? What is the difference between both the scenarios? In first scenario, the car crashes to the wall. It is a closed environment. It is just used by you. It is just for the fun. So it has no real impact. But when you actually build a real autonomous self-driving car, in that case, things get really destructive. It can harm people. At that time, we cannot just say that, okay, fine, it's fine if it crashes the wall. So at that time, we actually have to build the production level safety for this. This is a very simple example through which we can differentiate between what is the actual requirement for this AI agent to be production ready. We can simply understand like the when a toy car crashes, you can restart and you can move on. But when a real autonomous car crashes, it should not happen. Like the crash should be avoided. It should be actually detect all the scenarios. There are ADAS features. It should actually detect what is the obstacle coming from backside, from front side, and everywhere. It should convert like observability. It should actually detect the areas and all. And that things which we have to consider in a production system. But in a normal system, when it is just on your local system, we don't have to consider all these scenarios, right? So this is the very important thing. When the code is running on your laptop, you are only using it, no one else. But when the code is running on the server, there are thousands of concurrent requests that comes to your application. At that time, if anything breaks, that is a disaster for you as a product designer, right? Apart from that, if anything goes out of hand, if the AI agent replies not in the correct manner to you, it is fine. It all right because you are the only user. But let's say you are actually using it in the production system. That is not fine there because it actually breaks the image of the product. It is actually not good. So their gap is real. The demo shipping in collab means nothing if you can't actually survive the real customers, real changes, and everyday interactions. Uh, I hope you guys understand what is the actual problem of the and what is the actual requirement for the production ready system. So there are five pillars that we have that are like non-negotiables for a system to be a production ready AI system. The first one is a very important, that is reliability. The production system should be reliable. It should be able to handle failures, retries, and timeouts gracefully. Just consider a scenario when you are actually trying to do a like having a word with a chatbot on a customer support. At that times, you explain your problem to the AI agent, and it tries to actually understand that. But in between, it actually breaks. What happens once that break? The system lose the context of what you actually asked for, right? Let's say you actually give the intent. Now the AI agent goes to the rags and the documents it have, and it tries to retrieve the information. And let's say the third step, then it have to generate the response using the LLMs behind. It crashes. At that time, it will retry automatically if the agent is production ready. But if the agent is not production ready, at that time it starts from the step one again, which is actually the intent description. You will have to explain the whole problem again to the AI agent, and then it again goes to the RAG, it retrieves the documents, and then it try to generate the response. And if it fails again, it does all three steps uselessly because it is not production ready. But in the case of production, you cannot afford these many multiple tries, right? It is actually costing you each API call, which will indeed increase the price for the product, right? So that time we use LangGraph. LangGraph is a technology. Just consider it as a flow chart. You have a flow chart in that the flow is described. First thing is classifying intent. Second node is for about like retrieving document. Third node is for generating response. Fourth node is for let's say confidence check. And the final node is about sending or escalating the response. At that time, what happens? Just imagine, visualize this flowchart, and now just try to convert this flowchart into a code. That is what exactly LangGraph does. LangGraph actually consists of nodes and edges, and these actually nodes have the rules or description of what you need to do at each step, and the edges is how the data flows from each node. And this is a stateful thing. What the stateful means, every node has information, stored its information, and when it moves on to the next node, the information is still stored with the node. The information is not erased. That is how LangGraph works. So if we move back to the scenario that we discussed earlier, you are on a customer support customer support chat bot. At that time, what happens if you just crash on the third step, which is generating response? It doesn't start from the step one. It starts straightly from the step three, which is generating response. It doesn't go back and take the input from user. It doesn't go back to the RAG and retrieve the document. It straight away start from the state three, which is the failure point. That is how actual production grade reliable system works. Second is important pillar in this is observability. uh, Observability is like whenever there is some kind of failure that happens, like in the third step, the failure happened. But if we don't observe that, how are we going to know that the failure happened in the third step? Like, just imagine, how are you going to find that? Because the API logs are really messy and they don't store it for a long time. It is like this temporary storage. So how are you going to actually do the observation, and how are you going to know that whether the where the error occurred and where the log uh, got the error? So at that time, what we do, we use Langsmith. Langsmith is a tool that we use for the observability purpose. When we attach the Langsmith with our code, what it gives us? It gives us the context of RAG, what retrieved from RAG. Secondly, it gives us what the prompt went from a user and what is the exact output that LLM gave back to the user. It also gives the confidence score, what was the confidence score, and also the count of tokens, how many tokens actually did the intent give. And that time we actually have the information of every single thing and every point of failure that can happen. And now we since have all the data, all the information, using Langsmith, we can simply find out that and just go and fix that in minutes. Before this thing, without using Langsmith, you will have to manually find that out, and that will be a hell of a task. uh, Third pillar is cost control, because when you are building production thing, you are building it for masses, and at the end, when you are building a product, you aim to get some kind of profit from it. But if your API calls and LLM calls only drains whole of your budgets, how are you going to basically earn? How are you going to be profitable? And that is where the cost control thing comes into picture. Let's say, just imagine when we use the Claude Opus model, it actually has the cost around $15 per input money tokens. And if we consider 500 conversations per day, it will cost us around 25 to $30 per input conversation. And now doing the math, the output token will also cost around same thing. Let's say 50 to 40 to $50 per day we are spending on API calls. That is roughly around $1,200. Can you imagine how big this number will be when we increase to more conversations per day? And exactly that is where we need to do the cost control. Cost control can be done multiple ways. The first is actually we can cache the repetitive things. Let's say you are not able to log in, and the logging in issue might be a repetitive task. So we just cache it. And let's say multiple user ask, I am not able to log into the system, not able to log into the system. At that time, what we do, we just give the response from the cache, whatever we have done. Secondly, we can actually switch between models. We know Claude Opus or some big models, they are very costly, and we don't want to waste those tokens for the small cheaper tasks like the classification or choosing of anything. At that time, what we do, we use the cheaper models, which actually reduce the cost significantly. Let's say if we use Claude Haiku instead of Claude Opus, the API cost will be reduced significantly, like up to 25 times the API cost will be reduced. And that is a significant saving in the API cost. And third thing is batch API. What does batch API do? Let's say the task which you assign to the API AI is not required immediately. The output is not required immediately. So we create a batch API task. In that, what happens? Let's say you put the input at 9 p.m. You expect the output by 9 a.m. So it just streamlines the task and manages the traffic accordingly. The fourth pillar is safety, because since AI is unreliable, as we know, because if it is done without any safety safeguard, it can just go wild with anything. There was a recent scenario which happened with the Air Canada, that the customer came to support agent, and AI answered him with some vague thing with hallucination, and the person sued Air Canada. At that time, what happened? The Air Canada lost this case because the AI agent actually hallucinated without proper safety. And we know this thing is very serious. It can make the things and break the things as well. So in that case, what we use Guardrail AI. Guardrail AI is a tool which can be used to actually verify the input as well as output. Let's say you, as a user, put something in the chat box. What happens? The input is passed through Guardrail AI, and now Guardrail, it analyzes it. It checks if there is something which is actually, let's say, uh, what do we say? It is something like harmful, or some response is like hate rate speech, or something which is trying to break the system. In that case, it doesn't allow that response to go to the API or LLM call. And let's say when the output is generated by the LLM, the same thing it does. It checks it, it verifies it. It checks if the output is actually coming from the docs, which we have actually given to the RAG, or it is just hallucinating and creating, making up things. This is the most important thing, the safety. And the final thing is scalability. Now, since you are using it as a single user, you don't need big Python APIs or something. You can just simply use Python function and just do the call. But let's say now you have 10,000 user on your AI agent. At that time, you will actually have to use the scalability, use fast API, and then we actually give it to the code. Like we use fast API in the code so that it is scalable and it can handle the multiple responses. Uh, Moving on to the second part. So this was the first mission that we accomplished. We were able to understand how the AI agent is problematic if it is not production ready and how it can break things. And that's how we cover the first task. In this, if you have any kind of doubt, just please put into the chats. So I see the one thing when we compare the response of Haiku and Opus, the quality of response differ. Exactly. At that time, what we do, we specify the agent to do specific tasks. Let's say if we want to just detect the intent of the input, at that time we use Haiku, which is a low priority task, right? We just have to detect the intent. But when we have to actually give the exact output, what is the remedy for it, what is the solution for your query? At that time, we use better models like Claude Opus or Claude Sonnet or any better model. In that way, we can optimize the cost. So the low priority things, low things are done using the lower models, and the high priority things are done using the best models, better models. Uh, can you just put anything in the chat so that I know that you guys are here and you guys are listening? Yes, please share the slides. Sure, we'll do this by the end of session. We'll share that. Okay, so now let's understand what are the design patterns. So just imagine design pattern as a pattern that we can observe everywhere. Design pattern is a technique of software engineering. Once you know the pattern, you will be able to see that everywhere. Every AI product, every startup, and every enterprise system, it has some kind of design patterns in it. Design pattern are, let's say, a template that every AI agent or AI system uses to actually be in the production ready thing. Let's understand these design patterns one by one. So there are majorly four design patterns that we use, and we are going to understand each one by one with a very simple analogy. Just put it in the chat if you are ready to get started with this. Okay, great. I can see the responses. Great. So let's start with the first pattern, that is sequential chain. Just by reading the name sequential chain, we can interpret what it actually means. It is something that happens in sequence and in a chain thing, like one after one, one after one. So what is sequential chain is the first input creates an output, and the output from the step one is the input for step two. That means the step two cannot be started without the completion of step one. Just understand with this analogy of a car assembly line. When you are on assembly line of a car manufacturing plant, the factory assembly line, right? So the first of all, to actually give the final output, which is car, we need a car body, we need a skeleton, we need a metal structure, right? That is the first step. And now the second step is we cannot just simply give the skeleton to everyone, right? We have to actually paint it and do some like beautification of it. And for that, we need the first step, that actual skeleton of a car, actual chassis, and then we can paint it. And once we have painted it, we can actually install the electronics and mechanics in it, like engines. And after that, we can do QA. So in this thing, we can simply see that each next step is dependent on the previous step. Each thing is very dependent. And that is like the dependency on the data. So when the dependency is prominently on data of the previous task, we use the sequential chaining. Sequential chaining, there is one drawback in this. You can just imagine. Let's say step one is complete, step two is complete. But when we come to the step three, if that fails, what happens to step one and step two? But as we learned earlier, we use Lang graph. In that, the states are actually stored the data what they are intended to. Like step one data is stored, step two's data is stored. So step we don't actually start from step one again. We just carry forward from step three. That is how we do the error propagation in this. There is a famous logic which we use, like the three time retry logic. We actually exponentially increase the time after each logic, after each retry. Let's say the first time failure happens after 4 seconds. What we do, we retry it, but this time we exponentially increase it. We wait for 8 seconds, and second time we wait for 12 seconds, and so on. We do this for 3 times. And after that, we actually give the response to the uh, Slack or Discord or Telegram, wherever we are actually logging the error to the developer. So this is what sequential chaining is. It is like the task is done one after another. Now, we know, like we want to understand where we use it. So it is used when the order is matter, the dependency on step is very critical, and how predictable we want the model to be. Uh, Now let's understand the second pattern, which is the router pattern. Can you just imagine what the router pattern can be? Just like understanding the word router, it relates something about routing. Like we are trying to route some kind of input. So let's say you are actually in a hospital and you go to the reception and you just have like you just got you fall from your vehicle, right? And you are badly injured in your arm. At that time, the receptionist won't send you to the fire emergency department, or it won't send you to, let's say, a eye specialist, right? It will actually send you to a orthopedic. This is exactly routing. Routing actually gives you the correct way for the correct intent. Let's say your intent is to go to the orthopedic, like the doctor who is very good with the arms and the bones. It routes you to that, not to the useless other doctors which are not useful for you at that moment. This is exactly what the AI agents and LLMs do. So when you as a customer comes to a business and you want to actually address the query which is related to the billing or financial thing, at that time, do you require something which is related to orders? Maybe no, not at all. You want to actually inquire about the payments and all, but you are being routed to the order history kind of agent. At that time, you will be annoyed and your time will be wasted. And that time, what we do, we use routing pattern. What does router pattern do? It detects the intent and it simply routes you to the perfect intent. Let's say if your query is about billing, it routes you to the billing agent. If your query is regarding technical stuff, it routes you to the technical stuff. If your billing is regarding to your order history or something other, it routes you to that way. This is how we use the router pattern. So router pattern is majorly rule based. Router never solves. It delegates the task. It is like the orchestrator. It is like the big boss on the top, and now it suggests you to go on whichever path you are actually wanting to go, and not just miss out on what path you want to go. The third part is about parallel fan out. So what does parallel fan out means? Imagine you are doing one task. You are taking water out of a well. If you are doing it alone, it will take a lot of time. But let's say 10 people are simultaneously taking water out of the well. It will complete the task in significantly low time, right? This is exactly what we do in parallel fan out. Let's say you are actually wanting to do something with the code, and you ask it AI agent to write a code about creating an admin dashboard. At that time, what can happen? You don't have the whole knowledge about how the admin dashboard should look like and all. So what you do, you ask your AI agent to actually go to the web and search for all the information that is available about building admin dashboard, how it should look like, and then find out the best pattern that is recognized, like that is required for our system what we are building, and then build it. So In this, we can see briefly there are three steps involved. First is searching the web for understanding how the admin dashboard should look like, right? And how the industry standards are, how the people actually build admin dashboard. Second thing is what are our requirements, our system requires, right? And third thing is actually building it. And just wait for a second. And can you think like these are tasks that can be parallelized? At that mean no task is dependent on other tasks. Let's say the task one, which is about web search, is not dependent on the second task, which is understanding the requirement of our system. So in that case, what we can do, we can deploy parallel agents. A first agent goes and scrape the insight from web search, and the second agent goes and scrape the information from our own code base. At that time, what we can do, we can parallelize the task and save the time efficiently. And once we have the information from the best practices available on web and what are our requirements, we combine both of them, and when we provide the information to the third agent, which is actually going to code a admin dashboard for us. So this is a very simple analogy which we can understand what is the parallel fan out. So when we use parallel fan out, when we actually have to speed up the task, when the task which we are wanting to do are not dependent on each other, they can be parallelized and they are independent. Uh, and you can imagine like each API call, let's say each call, each work take 3 seconds. So doing one by one, it will take more than 6 seconds, right? Because we have to do it twice. But let's say if we parallelize those tasks at that time, those both tasks are doing simultaneously. So we save the time significantly. But you might think that it will actually reduce the cost. So no, that is not true in this case. The cost of the API will be still similar, but the time is the most important factor that is actually controlled over here. Also, in this case, we can delegate the AI agent or LLM which we are going to use. We can decide which task can be done by which AI agent. We can do the simpler task with the cheaper AI and more complex task with the costlier AI. Now, the fourth and the most important pattern that actually makes the AI agent be a production ready AI agent is human in the loop. Now, you might think, why we need human when we have AI agents, right? We are using AI agent to automate the task for humans, but now we are introducing a human in AI agent. Why is this required? But that is the most important thing. You remember earlier I said you one analogy or one case that happened with Air Canada. That can happen with anyone, right? And if there was a human involved in that case, would you think this thing would have happened like the customer would get the wrong information or the company would get sued for propagating wrong information, which was not even their mistake? No, not at all. So we don't aim to remove the whole human task force with the AI agent, but we try to reduce their involvement by more than 90%. Earlier, if we would have used 10 more than 10 people, now we can use only one people. One person can does the whole job because the only tasks which are very difficult for the humans machine to understand are escalated to human. At that time, the efficiency of human is also increased. At the same time, we can improve the AI to actually solve the thing. And how do we decide which thing is to be delegated to human and which thing is to be handled by the machine AI itself? So the analogy is very simple. Intern pushes the code to the main without senior review. You are an intern in a company and you push the code to the actual production thing. At that time, you will actually miss things. You actually wait for the senior reviewer to wait, like in the open source contribution, right? When you do the contribution, you wait for the reviewer to review your code and then merge to the main. You don't directly merge the code to the main, right? And that is what we are trying to understand. Let's say you are having a query, we give it a confidence score. Like if the AI agent is confident, only and only then we will give the output. Other than that, no, we won't give the output. The standard confidence score lies between somewhere around 0.75. So if the confidence score is greater than 0.75, only then the thing will be handled by AI. Other than that, it will be escalated to human. So now the question might arise, how do we calculate the confidence score? There are multiple ways which we can do it. The first and the very simple way we can use it, we can ask the AI itself to give the confidence. Let's say we ask it, what is the confidence score? If it is gives more than 0.75, it is good to go. But as we know, AI sometimes can hallucinate, so we don't rely on that completely. The second option which we do use is RAGAS. What is RAGAS? It is Retrieval Augmented Generation Assessment. It assesses the actual score of the output that is generated, that is processed, and then it gives the score. And the third one is actually semantic similarity. Semantic search, which we use in the vectors and racks, is what we use semantic score. We take average of all the score, like the rating from LLM itself. Second one is RAGAS, and third one is semantic similarity. And then we take average of all of them, and then we give the confidence score. And if that confidence score is greater than 0.75, only and only then the machine or the AI itself does the task. Other than that, we don't do the task. Right? Uh, so this is where we actually come to the end of second mission, which we were wanting to do. So we are almost half the way through the session. So I just want to know if everyone is overwhelmed or able to process whatever we have understood till now. Can you just quickly spam that in chat if you are able to understand? Just put thumbs ups or yes in the chat so that I know you guys are still there with me. Yep. Okay. Any responses? Anyone in the comments? All right. All right. So we are already halfway through the session. And now it's the time. We understand everything. Why we need the production ready agent, how we design the production ready agent, what is the template we need to design it. But now it is the very, very important task, which is we need to decide which tools are we going to use to make the production level AI agent possible. uh, so I think you can asking for quick overview. So okay, quick overview is like firstly we started with understanding problem, why we need the production ready AI agent, why we cannot use the normal Colab notebooks, and why we actually need the production thing. And the second thing was design pattern. What are the standard templates? Now, since we discussed the four templates, you can go to any website, any agent, anywhere, and you can find those patterns, what pattern it might be using. One more important thing you might think, like these patterns are used individually, but no, that is not true. In the production, when the agent is actually been developed in production, we use the combination of all these four design patterns. These all four design patterns are used one by one, one after one in a sequence, so that the system is not breaking. Right. Let's move on to the third thing, which is the selection of the tools and selection of the weapons that we are going to use to conquer the production readiness of the AI agent. Uh, so we can understand each agent, each tool with one use case. Let's say first tool which we are using for is reliability. So, as we know, the five pillars: reliability, observability, cost control, safety, and scalability. These are the five pillars of the production AI agent, and we have to tick mark each and every one. So you don't need to memorize all the tools and just remember, okay, this tool is used for this tool is used for that. No, 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 no. Just simply listen to me and just understand what is the use case of each tool, when it is used and when it should be used. And whenever you're trying to build it, it will just fall back to you naturally. Okay, so this is my use case, and in that use case, I will be using this. No need to memorize these tools and everything. So first is reliability. For reliability, we use LangGraph or temporals. Now, understanding what is LangGraph. LangGraph, we know it converts, let's say, the flow chart kind of thing into code. Each node is a state and it saves the information. LangGraph is good for workflow that is completed in seconds. You are sitting in a chat agent and you are having a conversation with the AI agent, and you want the reply to be in like max 1 to 2 seconds, 3 seconds, not more than that. At that time, we use LangGraph. But the other okay. So, but the second one, which is temporal, when we use temporal, it is used when we have actually more time window for us to complete some task. Let's say you are in a big, let's say you are working for Amazon. So at Amazon, you will have to you are assigned a task to analyze the sales of a week. So what you do, you create a agent which actually reads the data every 6 hours. So every 6 hours it reads the sales data, and at the end, like to the Friday when there is a weekend, it gives you a weekly summary report of sales. So in that case, do you think we require the response to be generated within like 1 or 2 seconds, or in like very small span of time? No. In that case, we have a huge time gap for us, right? So in that case, we use temporal. When the time is not a restrictive factor, when we have to process the data from multiple days. So for reliability, we use either line graph or temporals. Now you might think, should we use them together or not? So no, there is no need to use both of them together because the both use cases are completely separate. The chatbot use case is separate, and understanding the sales data is a complete separate use case. Now the second pillar, which is observability. For that, again, we have more tools. First one, which we earlier only heard, is Langsmith. It logs each and every single line of data, like what was the input from the user, what was the output generated, what was the uh, token cost, and everything. So for that, we use Langsmith, which is a fully deployed on cloud, and you can just use it using a API. But other than that, the second option which we have is LangFuse. LangFuse is a open source option that does similar purpose of LangChain. It is open source and it is self-hosted. So let's say you are actually working for a finance firm, or you are working for a hospital, or a legal advisor. At that time, you want to create an AI agent. The information that those firms and organizations have is very critical, and they don't want to be it public or on the cloud so that anyone can access it by some minimal practices, right? So in that case, what we use LangFuse. LangFuse is a self-deployed version. In that case, what happens? The We have an overhead of deploying the agents, but still we have the safety and integrity of the data maintained so that we can use LangFuse. And the last one is Helicon. Helicon is the simplest and most easiest one error logging system that we can use. It is just like one line of code, you add it in, and you get like logging of each and every line of code. The third part is cost control. As we discussed earlier, cost control can be done using three methods. First is batch API. We actually batch the task, and only then we give it to the API, which is not required immediately. Secondly, we use the cheaper models. And third one is we use cache. What the cache do? It actually shows the response which are of the frequently asked questions, and then it gives to the user. So it doesn't hit the API call again and again, which significantly reduces the cost. The fourth one is safety. So for safety, we use Guardrail AI, Nemo AI, and System Prompt. So what Guardrail AI does, as we understood earlier only, Guardrail AI analyzes the input and checks its description. And while giving the output as well, it checks the description and sees if that is appropriate or not, if it is being served from our databases or not, right? And what about Nemo? Nemo is a again open source version of Guardrail AI, which is developed by NVIDIA. It is used in the places where the regulation is very stricter, or when you want to actually do the things in like secretive way or very controlled manner. That time we use Nemo by NVIDIA, right? And the final thing is system prompt. What is the prompt that begins the AI? Is the system prompt. When we inject any prompt like to the AI agent, we actually give the user input plus the system prompt, and only then the AI processes it. So the safety can be very much restricted using the system prompt. And the final one is scalability. For scalability, we use Fast API. As we know, for the Python, there are multiple frameworks which we can use for the website. First one is Django. second one is Flask, and third one is Fast API. So why don't we use Flask and Django? Is a very simple reason. For Django, it is a very heavy thing. It actually handles the authentication, the databases, and everything. But for AI agent, we don't actually need that kind of thing. Now coming to the Flask, why are we not using Flask? Since we know the AI wants response should be asynchronous and concurrent requests should be handled. Flask is by default a synchronous process. It doesn't handle the asynchronous process. So we don't use Flask as well. And Fast API, it is just a simple Python framework which gives us a synchronous thing inbuilt. That is why we use Fast API. And then we use Docker. Docker is very important for any code or any production ready thing to be deployed. Why? The reason being, let's say on your environment, you are working on a Python version, which is the latest version. But on, let's say, when you deployed the agent on server, the server is using the older versions of Python. At that time, the version mismatch can crash the agent in the deployment. And that is what we don't want. So what we do, we create a container, we create a box, we put all the important files, all the important versions, all the important environment variables we want the system to use so that it survives perfectly on the server. And we use the exact same container. So if the container is, let's say, on AWS EC2 or on your laptop of Windows or your friend's laptop on Mac or wherever, it will behave similar just because we are using Docker. So it standardizes the process of how the AI agents and all are made. Uh, with this, we have actually conquered the third mission of the day, which is understanding the weapons and tools which we want to use. Now let's come to the final uh, thing, which is building and shipping. This is the final mission. So are you all ready to just dive into this thing? Just put in the comments you are ready to ship, build. Just show me your excitement so that you can understand how to build this thing so that we can put all the pieces together. Quickly in the comments. Okay. Yes, everyone. If you have any kind of doubts or anything, please put in the comments so that we can just clarify. Let's keep this session very interactive and very useful for you so that you get a value from it. All right. This is the final mission, and we all are going to together conquer this. And the final mission is building and shipping the AI agents. So, putting all this piece together, we will be understanding this with the help of a real life example. We will be trying to design an architecture of a real world chat agent that handles 500 responses per day. Are you ready to dive in? Okay, let's go. Uh, so as you can see this is like a architecture of a customer support agent, which is built for handling 500 tickets per day. So why are we using customer support agent? Like you might think, we can use any agent we can build. Yes, we can. But why are we using it? Because this is the one of the most mainstream use case of AI agent that we actually interact on the daily basis. You can actually search about this, the Intercomfine, Zendesk AI, and Freshdesk. These are the actual production-ready use case implementation of the customer support agent, and the architecture behind it is very simple that we all have just learned, right? So, starting with the user prompt, how does the thing start? So first is user. User gives the input. User gives the input. Now the input is broken down into the like the text format. It is understood to the semantics and word matching. And then we decide the intent. What happens? The input goes to router. Now in router, the second phase we can see here in the router, the intent of the user's input is detected. We can actually just spot the words, let's say billing, tech, and general, and simply classifies it. But sometimes the issue might not be very straightforward. But at the end, we know it can concise to the billing. So what happens? It will go to the billing wala route. You can see this billing route, and then it access the data and the knowledge from the knowledge base of billing documents. Then if it is tech related, it goes to tech, and if it is general, it goes to general. Now from each docs, it goes to the LLM. What LLM gets a system prompt, a user input, what is the query from user, and the documents from the RAG, the knowledge base. And all these three combined is given to LLM. Maybe a API from Claude, maybe a API from GPT, Grok, anyone. And the LLM processes this and it gives it to a confidence score. You can see this the second last stage here. The guardrail AI is sitting. It actually detects the exact thing what the LLM has given as an output, and then we give it a confidence score. If the confidence score is greater than 0.75, it is handled by AI itself, but it is low, it is handled by human agents. Here you can see these two things, Langsmith and Ragas. These are not into the flow, but you can see these are moving alongside the flow. So we can understand what Langsmith does. It actually starts the from the very first point when the user gives prompt. So Langsmith is the error tracking thing which we discussed earlier. So when the prompt goes to the agent, it is logged by the Langsmith. Now the Langsmith has logged everything, which route it takes, how much context it has, which document it accesses, and everything. So that if at any point of time there is failure, we can handle that safely. And the second is Ragas. Ragas is again RAG uh, assessment. It gives the score so that the confidence can be detected. Right. Let's move on to the next flow. So this is a simple summary of what we have done till now. Just sit tight and just try to go with me in this flow. The tool you are using behind this flow. First one is we use and actually index the docs. So what happens? You as a company, you have some kind of documentation, right? You give it to the vector databases for the you retrieval from the RAG, which is index. We have to index that. So for that we use Llama index and Chroma DB. At that time, what happens? Let's say the message is received by the AI agent. The message hits to the fast API. The fast API receives the message from the browser. Now it is routed to the land graph. The land graph is the flow which we earlier studied, that step one, step two, step three. It absorbs it. And then Llama index, it actually retrieves the documents which we want for the completion of the intent. And then what happens? The fast API and land graph decide the route. Which path will the intent take? Will it go to the billing? Will it go to the technical part? Or will it go to the general part? Then we actually generate the response from Claude API or any API which we are using. And then the final thing is validating and tracing. We use guardrails and Langsmith to validate the API, validate the response. And if by any chance guardrail detects that this is not the appropriate thing, we use Langsmith to detect which step failed and due to which step this thing is not appropriate. Uh, that's it. That is all about how are we going to build a production ready AI agent. Uh, for this AI agent to be very safe, what we do, we use a isolated environment where every destructive action needs human approval. Guardrail validates all output, and the AI is never confused with that. The guardrail actually helps us to overcome the challenges of like the personal information revealing from the databases and everything. So that is how we can build a production ready AI agent. So let's move to the next point. So now, as we see that we have completed all the four missions in this session. The first one was understanding the problem. The second mission, which we accomplished together, was understanding the patterns, like we are able to now detect the patterns what the agent is using behind it, right? The third one which we accomplished was about the tools the AI is going to use, we are going to use to make the AI production ready. And the final one was about shipping. uh, so if you guys have any kind of doubt or any kind of query with this thing which we have covered till now, please put it in the chats. Yes, anyone, if you have anything, please put it in the chat so that we can actually understand if we are not able to get something or not. All right. So just I want to tell you one thing, which is apart from all this thing. Let's say after this session, there will be few people who will actually listen to this session and post about it, or like a blog kind of thing. Like we have learned about the building production ready agent and all. But the one who actually builds a project instead of writing a blog will understand this whole thing a far better way than that person. Like a production agent, you shipped with 100 medium articles about LangGraph. Okay, so what pattern does GPT use? GPT is like the LLM. It doesn't actually use, it is not a AI agent, it is a LLM. So it depends on what input you give. You can execute. So now it's your turn. I am done from my side, but you will have to actually build this agent now because it is the time, because everyone is building it and you cannot lag behind. So what you do, you build the smart agent, you have to ship it on Smartly Labs, and you can prove that everyone that you can actually build a production grade AI agent. Now you have your quest to do. The first part is build a basic router script. Let's keep it very, very simple. Before you hop on to the next session, which is day after tomorrow, you have to do this three simple tasks. First one is building a basic router script. Router script is like just where the response will go, like to the sales agent or support agent or billing agent, and just give the output of that. Like that's it. That is what we expect from the router script. Second one, add the Langsmith to any LLM script you want to add. Langsmith for the error logging and everything. And you can simply go to the Langsmith page, and then you can actually see the observe the how AI LLM behaves, right? And the final step is build the support agent from slide 11. We will be sharing all the slides with you in the chat once the session is about to be done. And at that time, go to the previous slide, and see the architecture and try to build the similar kind of thing with you on your system. And then you deploy it on Smartly Labs, where you can actually showcase your portfolio. Smartly Labs provides you a platform where you can showcase, when you can flaunt your works, whatever you have done till now, right? Okay, so this slide is like the whole summary of what we have done till now. Just take a screenshot of it. It is just a summary of what we have done till now. Index your docs, build the router, connect the retrieval generation, add a human escalation, add Langsmith tracing, and simply deploy it. Before closing the session, I want you guys to bookmark these three pages. First one is Llama Index Quick Start, so that you understand how the documents are being indexed and you can get started with it. Second is Langsmith Free Tier. As we all are developers and builders, we don't need the actual paid versions. So you can start with the free tires and explore, get your hand dirty with it. And finally, you can simply go to labs.smartly.ventures, and there you can understand how you are going to deploy the agents to Smartly Lab. And I won't reveal a lot of things because there are so many things that are yet to be done in the next session. And while we come to the end of this session, you will be able to showcase your work, showcase your portfolios publicly on web. Like let's say you can add the link which the Smartly Labs will provide you into your resumes and portfolios. And then people can actually see what you have built, what you have done, and use it. That's it from my side. I would want you to please feel free to ask me anything in the chat section about the session or what you have not understood. And yeah, the floor is now open. You can ask me the questions. Sure, you can connect with me on LinkedIn maybe. Just type my name, Anirudh. You can find me there. We can connect over LinkedIn. And also, I will try to uh, share the PPTs with you maybe after this session. You can find that in the pinned comments, right? Or you can just get this URL maybe. Yeah, hold on. You can see this URL. Just copy this. Try to be like screenshot this URL, and you will be able to go to this slides. And if you have anything, just reach out to me. Feel free to reach out. We'll be very glad to solve your doubts. Yes, anyone, if you want to put anything, just put it into the chats. Can you just tell me like how many of you like actually like this session, or how many of you are going to build this things ahead? Just tell me. Like I would like to know what you have built in now, or anything you want to just share with everyone. Okay, so I don't see any kind of doubts or such comments in the chat. So I will like to conclude this session from my side. Thank you so much, everyone, for patiently listening to me. And I will love to hear queries from you by any chance. If you want, if you have any doubts, connect to me on my LinkedIn, connect with me on GitHub in anywhere, and just build it, build things. Don't wait for anything, don't wait for right time, just start building things. You will learn it on the go. No worries at all, right? All right, then in the next upcoming sessions you will understand more about Smartly Labs and about build deploying the agents through Smartly Labs, and how you can use it and showcase it. That's it from my side. Thank you so much, everyone. Thank you so much.